So third page, we're asked to sketch a graph that has the following two properties. It has a domain that ranges from starting at -2 all the way up to and including -3. This symbol is less than. It means that it can't be -2 itself, but it has to begin there. So we're going to exclude that endpoint. And then this is including this endpoint. So what this means, right, is that somewhere this function has to be colored in this particular range, right? So here's where x is -2. And it has to be somewhere along that line. And here's where x is the number 3. I'm going to put a solid line here because it can include that. So any function that I write, for example, just considering this part of it, right? Just this domain part. For example, I could start here with an open circle and then just include the stuff that goes to here. And I could have like a closed circle here. Well, that would fit this first part because you can see every single value of x that's greater than -2 and less than or equal to 3 has an output value. It doesn't matter what x value you pick along this domain, every single one of them has an output value. So for example, if x is -1, there's an output value right here, right? Somewhere around this value. It's like 1, 2, 3, 4, a little bit like between 4 and 5, 4.5. So that's one of the constraints, right? The domain has to be between -2, not including the endpoint, up to and including 3. The other constraint is that the range, right, those are the maximum and the minimum y values. The range has to go between y is greater than or equal to -1, but less than 5. So I'll use an orange pen for this. So here, right, greater than or equal to -1. So this is a solid line. And my y values have to definitely hit that low point at some point and include it. And the other point up here is less than 5. So this is not included, right? But it has to hit just right up to this point, but not included. Okay, so there's a little, rectangular window there that this function has to live inside of. And there's a lot of different things I could pick that would fit in there. I'm going to pick the following. I'm going to have an open circle right here where this meets. Then I'm just going to have this curve kind of go down quickly and hit this number -1. And then I'm going to just have it come up, and I'm just going to have it land right here. And this has to be a solid dot. So something like that would be fine. Right? There's a lot of different things we could do. We could do something much simpler than that too. There's no reason why we couldn't. I don't want to go. There's no reason why we couldn't just start right here with the. Has to be an open dot up there, and just run this down, and just put a solid dot right here, right? So that works also. The thing is that you can see the minimum y value I get is -1. The maximum is almost to 5, right? Just right below 5, not including 5. And then x's are defined between -2 and 3. Let's move on to number 9. Number 9, it says simplify. I've got here two things that are being multiplied. And if I was to write them out longhand, this would be an x and then 3 factors of y. So x, y, y, y. And then I've got x, x, and then a y. So when I look at this, right, I know and I understand intuitively that multiplication is clearly commutative. 3 times 4 is 12, 4 times 3 is 12. I can flip the order that I'm multiplying things, and it doesn't change the value at all. So there's no reason why I couldn't rewrite this as 3 factors of x followed by 1, 2, 3, 4 factors of y. So you can see there I've got everything. Now, that's kind of an awkward way to write this. So what we do is we use exponential notation, or exponent notation. So I'm going to write, part of it's going to have a base of x with 3 of those factors, and a base of y with 4 of those factors. So that's my answer, x to the 3rd, y to the 4th. Let's take a look at question B. If I consider that numerator, the numerator is 3 times 5, and then I actually have 1, 2, 3 factors of h. And the denominator is 3 times h. And then I have also another factor of 2, a factor of 2, and an additional factor of 3. Well, both of these, right, have factors of 3, and they both have at least one factor of h. So in CP/M, they talked about, a big number 1. So if I look at this big 1, I could have a 3h and a 3h. And then what's left over, right, that's a big 1 right there. And then what's left over is I've got a 5 and an h and another h in the numerator. And then my denominator, I have a 2 and a 3. So if you look at it, right, anytime I'm multiplying something by 1, I don't change the value. So this big 1 is exactly that. It's the number 1. 3h over 3h is equal to 1. So what I'm left with is 5h squared over 6. And you can see, I don't know where that just went to. I'm sorry. I have 5h squared over the number 6. Okay, let's go down to 10. 10, there were three expressions, all involving exponents. In A, you can see we've got this m to the 0 power. And I think most of us are comfortable with the fact that m to the 0 power is equal to 1. The next thing I've got is an m and then two more factors of m. So if I write it out, there's an m and then an m and another m. So in my numerator right now, I have 3 factors of m. I could write that as m to the third. Now my denominator has m to the negative 1 power. M to the negative 1 power. And a lot of you were tempted on the study team test to just go ahead and call that m squared. And I just want to be careful and make sure we understand what m to the negative 1 power really is. So let's have a little brief discussion about what m to the negative 1 power means. In class we did something that looked kind of like this, and I don't know if I used 2 or not, but if we consider, for example, 2 to the 4th power, we understand that that's 4 factors of the number 2. And if I multiply those out, 2 times 2 is 4, times 2 is 8, times 2 is 16. 2 to the 3rd is 3 factors. I'm sorry, I don't know why I wrote the 3. It's 3 factors of the number 2. 1, 2, 3. And when we multiply those out, we get the number 8. 2 squared is just 2 factors of 2, which is 4. 2 to the 1st power is just a single factor of 2, which is equal to 2. 2 to the 0 power. Now, if you're stuck, let's just kind of inductively look at what's happening here. As I follow this pattern of decreasing my exponents, notice I go from 16 to 8. I get there by dividing by 2. Next, 8 divided by 2 is 4. 4 divided by 2 is 2. And if I go to the next step, 2 divided by 2 would equal 1. So this is an inductive argument as to why it is that 2 to the 0 power equals 1. And you know what? I want to take this one step further. That was all off the screen. I'm sorry. If I take it one step further, 2 to the negative 1 power, right? Well, just think about what we're doing each time we're dividing by 2. So if I take my number 1 and I divide it by 2, I get 1/2. And that's the idea I want us to kind of focus on, right? A base raised to a negative exponent, 2 to the negative 1 power, is equivalent to 1 over 2 to the 1st power. So I'm able to get a positive exponent by moving this down into the denominator. So if I consider this problem, what I have here is I have m to the 3rd power divided by 1 over m. Now I can take this another step further, and I will. If I'm dividing by a fraction, I know that that's equivalent to multiplying by the reciprocal. So I can look at m to the 3rd over 1, and I can multiply that by the reciprocal of 1 over m, which is m over 1. You can see what I'm left with then in my numerator is m times an additional factor of m. So this is m to the 4th power. And that was A. I've made a mess out of all of this area for b. Let me erase all that. Well, I'm kind of glad that we got a chance to talk about this negative exponent thing, because I can use that for b. Remember what we were saying was, and I showed this with a 2, we were showing that 2 to the negative 1 power equals 1/2. But I could extend that to, well, 1 over, I could write it as 2 to the first power. I could extend that to any variable, and it doesn't have to be just to the first, it could be to the second power also. So if I look at b, right, in what I have here is I have a b, and then I've got times 2b cubed to the negative second. Well, in order to deal with that negative 2 exponent, I'm just going to use this relationship, right? And I'm going to write it as 2b cubed, and it's going to be to the positive second. So now I don't have to deal with the negative exponent anymore by relocating those factors of 2b cubed into my denominator. I now have a positive 2 exponent. So what is that thing then, the denominator? Well, I've got 2 factors of 2b cubed. So in my numerator, I've got a b, but then in my denominator, I've got 2bbb, right? That's a 2b cubed, and another 2bbb. So if you look at it, and I know I don't need to write it out like this, you guys can do it probably, you know, using rules, but I just want to go back to what it is and why we're doing this. In my denominator right now, I have 2bbb, which is 2b to the 6th. And in my numerator, I just have a single factor of b. Now, if I have a b divided by bbb, right, there's a big 1 here, isn't there, right? In fact, I probably should write it like that. That's very, I like how they do that in this textbook. So I could write this as a b, let me clear this up. Let's do it like this. A b over 2b to the 5th times another b. So 2b to the 5th times another b is a big 1. So what I'm left with is just this factor of 1 in my numerator. My answer is 1 divided by 2b to the 5th power. Let me write that down. 1 divided by, did I say 2b to the 5th? I'm terrible. Many of you are probably screaming at me, Mr. Robert, you have 2 factors of b in the denominator, so that's 2 times 2, which is 4. So this is a 4b to the 6th, and yes, there definitely needs to be a factor of, erase. There needs to be a factor of 4 here, 4b to the 5th. So my answer is 1 over 4b to the 5th power. That was embarrassing. Let's see, the last one here. You know, when I look at this, I've got two things that are exactly the same. Yeah, they're awkward, they're negative exponents. I could flip them. If I wanted, I could move them across, but it would just be t to the 3rd over t to the 3rd. The thing is I'm left with just a single factor of t. The answer to C is just a single factor of t. 11, there's 1, 2, 3 expressions that we need to simplify. And this is just going to be a matter of collecting up like terms. So when I look at this first part, right, I've got some x's, some x's, some x's. And the other thing that we have are some integers. So I've got a 6, a positive 1, and a negative 15. So if I combine up my x's, right, what I have is 9 of them, minus 4, which is 5, and then minus 2 more, which is 3. So I have 3 x's. And if I look at my integers, I've got 6 plus 1 is 7. And then I've got 7 minus 15 is going to be, what is that, negative 8. So my answer is 3x minus 8. On B, if you look, there's these beautiful parentheses, but the truth is there's nothing that's outside of them that needs to be distributed. So again, I'm just going to collect my like terms. This time there are 3 kinds of things going on, right? I've got x squareds. I've got 6 of them and then 2 more of them. I also have a negative 2. Hold on, I didn't want the same color for that because they're different things. I've also got a negative 2x and I've got a negative 7x. And the other thing we have here are these integers. I've got 5 and I've got negative 11. So if I combine my x squared, then I'll just go ahead and write my answer. I've got 6 plus 2 is 8 of them. So I've got 8x squared. And then I've got negative 2x and negative 7x, which is negative 9x. And then finally, when I combine 5 and negative 11, that gives me a negative 6. Last problem there is C. 7x squared minus 5 minus 2x minus 3. Ooh, geez. Well, let's see. Really, I've only got the 1x squared and the 1x term. So my answer is 7x squared minus 2x. But then I've got to combine a 5, negative 5 and a 5. That's easy. That's a bunch of zeros. So that's nothing. They cancel each other out. Negative 5 and the plus 5 is 0. And then I've got a negative 3. So that's my answers for 11. 3x minus 8, 8x squared minus 9x minus 6, 7x squared minus 2x minus 3.